So, good afternoon, everyone. Welcome to another session of the CODA webinar series all about decommissioning. Today, thank you for joining us. We will be hearing from Jim Gordon, who is Sentinel's Business Development Manager, and he will walk us through Sentinel's passive technology and explore how these solutions support risk-based decommissioning decisions, enhance well suspension planning, and deliver both cost and environmental benefits, alongside real-world insights from deployments offshore. Remember, there will be a Q&A at the end of the presentation, so pop your questions into the Q&A section and we'll get to your questions afterwards. I'm really looking forward to this, so let's not delay any longer and let me hand over to Jim Gordon to take it from here.
Thank you very much, everyone, for joining today. Today, what I'm going to be discussing is our passive well technology that, as Rean mentioned there, is designed to help make risk-based decisions around well decommissioning and take some of the complexity out of monitoring and managing your subsea asset integrity, particularly around remote wells and in that decommissioning area where we can really add a lot of value to your subsea operations and well integrity and decommissioning planning. So without further ado, let's see, hopefully this will work. So without further ado, there's kind of two key technologies that I want to talk about today. The first one of that is our globally deployed and successfully installed well Sentinel system. These are continuous integrity monitoring systems, and they're designed to detect releases from subsea wells earlier than ever before. And we've deployed these systems globally. And secondary is around a technology development that is using the same core technology, but using it in a slightly different way. And that is what we call our SafeDisc, which is a visual indication system for at-source characterization of subsea emissions. But the core of this technology is around what we call passive. And what that means is that we're able to detect and monitor subsea wells without the use of active power or any data communication. These systems are a physics and chemistry-based solution that is used to remove the complexity and add reliability to your subsea well monitoring needs and your well integrity challenges that you have. So I'm going to talk about the well Sentinel system first, and then I'll talk about the SafeDisc solutions as well and how this system fed in to our new SafeDisc technology. So firstly, a kind of a high-level overview as to what well Sentinel actually is and how it works. Firstly, we need to deploy a system, a gathering system, as we call it, onto a subsea well. Now, this is external to the wellbore, and it sits over the asset. And what that system is designed to do is capture any release in the subsea environment. Once that system's installed, including the monitoring part, it provides long-term continuous remote asset monitoring without costly intervention. It will sit there for 10 to 20 years, continuously monitoring without any intervention. But should there be a loss of containment from that asset, we detect that using what we call passive triggers. And I'll go into more detail of those, but those passive triggers detect without the use of any active electronics and without the use of any through-water data communication. And once they've detected, they release a buoyant alert beacon to surface that is individually coded to that well and will send an alert to the operator that there's been an integrity issue from that asset. So those are the kind of four key points that we discuss when we talk about our well Sentinel systems. Oh, sorry. So here's an example of two of our systems that we've deployed. And as you can see there, one of our systems is what we call our well Sentinel Coral, that's designed to monitor subsea wellheads. And one of our systems is what we call our well Sentinel Oyster, and that's designed to monitor subsea Christmas trees. But what these essentially are is they're a gathering system that's designed to focus any emission into what we call our monitoring module. And that monitoring module is where all the passive integrity monitoring, the alert beacon, and all the kind of real advanced technology sits, is in the pinnacle of those gathering structures, as you can see right in the top. And the purpose of the gathering structure is just to move that emission or that loss of containment into that area for the detection. As you can see here, we deployed numerous designs of gathering structure for numerous different applications. So we've got top left there for wellheads. We have some that have an external fin that's designed to allow emissions or release from external to the well casing or the wellhead itself. In the subsea environment, we have systems for subsea trees. We have smaller remote systems for areas of concern on a subsea tree, and we can do PLEMs, PLETs, and whatever subsea infrastructure you have. But the real core of that design is to gather any emission in the subsea environment and direct it into what we call our monitoring module that is set with our passive triggers. These triggers are the core of our technology, and they've been developed here in Scotland through work with Heriot-Watt University and tested and deployed offshore. And what these are is these buoyant triggers, these triggers, passive triggers as we call them, are locking in place a alert beacon that is locked into place by these triggers. And we have numerous different trigger types that we've developed. Firstly, we've developed a gas trigger, which will respond to thermogenic gas only. And I want to highlight that. The system will not respond to bubbly seabeds of biogenic source. These systems are designed to respond to thermogenic reservoir gas only. Oil, we have deployed and successfully detected liquid hydrocarbon releases. Tracer is where we actually started our system, was the idea of installing tracer fluid during your well abandonment program and then detecting that directly, and that's something we can do as well. And also we have CO2 triggers, and we're getting a lot of traction around CO2 monitoring for legacy wells as part of an MMV plan. And I'll talk a little bit about that in relation to later on. And we can mix and match triggers to hold that beacon in place. So if there's an oil well and a gas cap or whatever you want to detect, we can mix multiple triggers. But these triggers are designed to respond to one material in the subsea environment and absolutely nothing else that they may encounter typically in the subsea environment. So they are inert to everything else other than the material that you want to detect. And again, no active power and no active data communication. Completely passive system designed for reliability, designed for robustness. However, during that monitoring period the system's installed, should it come into contact with the material that it's been designed to detect, it will then, and there's a video here of one of our tests, I believe we actually did in Perth, that will then release that mechanically release that alert beacon to the surface, as you can see there. Once at surface, that beacon then turns on. While it's subsea, the beacon is what we call quiescent, but it basically goes to sleep. And the only thing it's checking is it at surface or is it not? And that's how we get the extended deployment with this beacon. We can change that, but once it's surface, turns on. That beacon is coded to that individual well. So if it was installed on well number 5213, there's a surfacing event, it will then send an automatic alert to the operator's response teams, alerting you that there has been a detection and that you need to go and investigate because there's a possible integrity issue with that subsea asset. So again, we can set that up however we want. We have our own portal that we can use, but we can also feed that alert directly to your onshore base or your onto your API or however that looks. We can set that alert up, but the idea here is that you're getting an instant alert once that beacon is surfaced, and you're then able to respond and get in the appropriate means to deal with that integrity issue. How do we know it works? Well, as I mentioned there, we've had multiple accurate detections of subsea releases from wells. This is an example of one where we detected a hydrocarbon release from a subsea well. This was a suspended well. We installed a coral, which is our wellhead system on there. The system accurately detected that. The beacon released and the operator got the alert. We've had that multiple times. We were able to then track that beacon and then recover the beacon. And in this instance, the operator was then able to reinstall that beacon once the integrity issue had been remediated. So again, just providing that kind of not just one use, we can then reuse parts of the equipment and reinstall. And I should mention as well that monitoring module part, the part where all the integrity monitoring technology sits, is actually ROV deployable and redeployable. So should you have a release, you can then go and remove the monitoring module and reinstall it, potentially with some of the added capability that we've developed. As part of the monitoring module, that integrity part, there's a piece at the bottom that will allow two additional means of monitoring and also flexibility to the system into there. Firstly, the silo can be fitted with what we call a sample capturing device. And what this will do is, if you do have a release from a subsea well, this will actually close a part of that monitoring module and will capture a piece of fluid that set off the triggers, so that you can then sample that. So again, just adding another capability to the system and allows for easy sampling of whatever set the system off. And secondary, another element that we can add into that monitoring module is what we call our flow diverter and measurement unit. And what that means is that we can actually add a little bit more flexibility to the system by setting a threshold to which the system will actually divert X away from the reaction chamber. And only once that threshold has been breached will the system allow for the passage of the material into that reaction chamber to set off the alert. So we're really going from a kind of on-off system alert to much more of a flexibility with, we will only receive the alert once we know it's gone above a certain level. And this has really got a lot of interest around monitoring for ongoing integrity challenges where there's a known rate of release. This system could be installed to provide an alert should that release get any worse, and help the operator manage that integrity challenge until such time as they can get the appropriate infrastructure in place to then remediate or fix that problem. So again, adding a lot more flexibility to the system and a lot more potential use for that system as well. So, well, Sentinel systems, we're building up a track record of deployments globally, from the UK, Gulf of Mexico, Brazil, Caspian Sea, Australia. We're really building a use case for the system around numerous different types of well applications, from monitoring of suspended or inactive wells to the right across the well life cycle. So we've had an operator in the North Sea who was drilling new development wells, and those wells were being suspended until such time as the infrastructure was coming into place to then fully complete that well. And in that instance, the operator installed these systems to provide that continuous monitoring during that suspension period. And also, we've also deployed numerous systems around producing subsea assets, where the operator is looking at providing a early detection capability much quicker than they would with their in-well and pressure and temperature gauges. In this instance, the operator was able to get the detection to 60 mils of fluid released. And that is a much quicker, much more risk-based, improved risk assessment for those subsea producing assets than what they had in place already. And finally, we had a case of an FPSO disconnected floataway that was associated with some well suspension in Australia as well. And I'll touch on those points as well, just to highlight a kind of real use case scenario that we had. So in this instance, the operator had two subsea development wells that were part of a 7-well cluster. In this instance, the wells were being temporarily suspended and the Christmas tree was being removed. These were 18 3/4 wellheads, and because the FPSO was moving away, what that meant is that those wells were disconnected from any means of active monitoring through the traditional means, either at tree or downhole or any other means. They were completely remote wells, and the operator in this instance was looking at how can we make risk-based continuous monitoring in place to lower the risk profile of those suspended subsea wells as part of that 7-well cluster. And as you can see here, the systems were successfully installed in a campaign, deployed through the use of ROV only. and also through the use of vessel crane. They were lifted from the vessel to the well site, installed. Both systems were installed in about 30 minutes per unit. So the system picked them up, they were all preset on deck. The system then, the vessel then lifted the corals, deployed them to the well site, set it over the wellhead, pulled one, what we call monkey's fist, to open up the reaction chamber to the wellbore itself. And that was the system monitoring. Very streamlined, very easy to use, deployed very quickly, and they are now have the continuous means of assurance and monitoring in place should anything happen at that well and there should be an integrity issue. So again, very successful deployment that we had. So ultimately, what the systems were able to do is we enhanced the risk management of those subsea wells. These systems are designed, I hope I explained that earlier with the overview of the well Sentinel system. These systems are designed for simplicity and reliability. We have eliminated false positives with the design of the system being so robust, and it's quite difficult to engineer. We always say difficult to engineer simplicity, but we've done that, and we've gone down that path so that the system is robust and easy to use. What that means is that we have improved the risk assessments of those subsea wells, and we have an ALARP demonstration of the decommissioning decisions that were made, and that is on a risk-based, case-by-case basis for those subsea wells. We were able to enable the continuous monitoring of those disconnected wells that was not possible without the use of this technology, and we reduced the need for costly offshore inspections. Go out and gather data from anything that was installed, or to go in and actually visually inspect the well. We're removing that. And what that means is that, especially for deep water environments, that's a huge safety and operational efficiency gain that the operator had. So on the right, you can see a small graph that I put together, and this is just demonstrative in terms of what the well Sentinel can do. But you can see there, with the well Sentinel installed, the operator has a continuous integrity picture of that subsea asset. And that's the real benefit of the technology is by de-risking and removing the uncertainty from those periods when the well is there's no one there. So again, providing continuous assurance that the well is secure, and that gives you a better risk assessment, and then gives you the ability to make decisions based on that assurance that you now have in place with the well Sentinel installed. So our enhanced monitoring system through the use of our passive technology is supporting risk-based decisions around well decommissioning and producing wells right across the well's life cycle. But in this instance, I'll talk about some of the benefits for well decommissioning. So it's a risk-based and cost-effective approach to subsea well monitoring, significantly reducing risk and giving you greater flexibility. The well Sentinel system drastically reduces risk uncertainty and provides that additional layer of assurance throughout the decommissioning process, opening up options for operators. The early detection in place, and as I mentioned, we can get that down to 60 mils of fluid. It's not that we can get it down to that, we can set that to whatever the operator wants, but that's the minimum. And we can rapidly identify any integrity issues before they escalate into anything, and before you can then mitigate for the environment. The continuous monitoring that's provided by the system supports verification across all decommissioning phases. And again, I mentioned there's no in-well intervention, which means safer, environmentally safer, and personnel safer, quicker and less complicated subsea operations. We support improved scheduling and minimizing risk, and then you can focus your means or your spend into where the risk areas are highest. We're taking operators into a space where they can then focus in on high risk areas using this technology. And finally, we have the technology reduces vessel-based scopes, lowering operational costs, obviously, because you're not going out to inspect or to physically inspect, or to gather data from some of the active systems. And we're also reducing greenhouse emissions. And that's critical in our industry now. We have a third-party report, actually, that shows some of the emissions, greenhouse gas emissions gains reduction gains that can be in place by just deploying these systems across a wide operational base. So multiple different benefits from using the technology across kind of end of life well decommissioning phase. I just want to talk on quickly about the technology as well, but that's being developed and used for CCUS projects, and really as an enabler for getting some of these CCUS projects across the line through a risk-based monitoring, measurement, and verification plan. And we're actually on two monitoring plans for two projects already. And these are around monitoring those legacy abandoned wells that were not designed. They were maybe decommissioned a long time ago, and they were not designed for the introduction of CO2 or to the repressurize of that reservoir. What we're able to do through the use of this technology is provide an effective means for monitoring those legacy wells and lowering that risk profile of the subsea well using this system. So how do we do that? Well, in this case, we install what we call our well Sentinel limpet. And what that is it's a mudline deployed system that sits over the previously abandoned well. It's, for want of a better word, a kind of umbrella that's designed to gather anything should it emanate through the mudline, CO2 or hydrocarbons as the well repressurizes. We fit the monitoring module. As I mentioned earlier, we can have multiple different types of triggers fitted into that system. We fit it with CO2 hydrocarbon triggers directly over that abandoned well. And once that's installed, it will monitor continuously, in this instance for however long the operator needs. The monitoring of that well is now in place. And should there be a CO2 release due to an integrity, it's then captured by the vertical through the mud line into that monitoring module and works exactly the same as our oil and gas-based systems that we've deployed already. So again, just another string in the bow in terms of supporting not only oil and gas operations, but also looking at CCUS and where we can take some of the complexity out of monitoring, because some of the key challenges that are around CCUS projects is around how can we cost effectively implement what we need to implement. And this is a means of doing that, providing up to 20 years plus of monitoring, no well intervention, the early detection of any integrity issues before they escalate, and we're optimizing that MMV plan and reducing cost and greenhouse gas emissions as part of that. And again, it's fishing friendly. This is actually designed to be fishing friendly, and we worked with design here to ensure that was the case as well. So again, just another part of that technology. So I guess that's kind of the Well Sentinel system, and we've deployed, as you've hopefully seen there, systems globally and majors, super majors, independent operators, and that's really gathering traction, and we're moving into supporting real value into the industry. But one of the core part of our technology is around those passive trigger technology that I mentioned. We're actually using that now, and we're developing this system and running it here. Is what we call our passive triggers, but used in a slightly different way, and that's to provide an at-source means of characterizing whatever release that you may encounter during your subsea inspections. And we do that through the use of the safe disk. And what that means is that we have an ROV tool that, should you see something, can be held over the bubble stream, shall we say, and by inserting the appropriate trigger that you want to detect, it will then give you a visual indication at source as to what that is. So an example for this that's getting a lot of interest is around the use of distinguishing between biogenic and thermogenic sources at source, rather than needing to sample that, take it back to surface, take it to the boat, chopper it out, or whatever you may need to do that, take it back to a lab, and then run the analysis on that. Can take weeks. By that point, you may not be in the area, you may have to go back. So again, by giving you that at the point, distinguish between thermogenic, biogenic, and thermogenic, you can then respond there and then when you've got the assets in place. And also there's a lot of HSE benefits, because rather than needing to sample every piece of whatever you see, you can now only respond when you know that that's a source that you need to deal with. So again, being able to distinguish between thermogenic and biogenic sources much quicker, much easier, much less complexity, much safer, really is a big industry gain, and it's using the same technology that we've already field proven and deployed already. And here's just an example of the system here, inspecting a subsea tree. The ROV goes down with the ROV manipulator and the handle in place, holds it over there, and it'll give you that visual indication as the buoyant emission travels through that funnel there and into the over the passive trigger. So again, just an easy to use system, very a lot of value added by using that as well. So and I guess how else can it be deployed? Well, we're also looking at putting this as a static deployment or a continued deployment over areas or valves or whatever you need, where you can install that with a magnetic clamp or another clamp in place. And then during your GVI, you would go and have a look. It's kind of like a litmus test for your boiler or a CO2 strip in place. So again, installed into awkward places potentially, and you would sit that over the asset that you want to monitor, and it provides that very quick visual indication that something has been passed over that has then interacted with those triggers and has given you that visual alert. So again, great flexibility with the system, and we're really excited about what we can bring to the industry with this in removing a lot of complexity from your subsea monitoring and subsea operations, both with the Well Sentinel and with the Safe Disk technology. So that was a very quick, very high-level overview of the technology. I hope that I've given some food for thought in terms of some of the people here about how the technology can be used to improve the risk assessments of subsea wells where there's risk, and remove a lot of the complexity out of then managing that risk and providing a cost-effective manner of doing that, both with our Well Sentinel and our Safe Disk technology. So thank you everyone for listening, and I'm more than happy to answer any questions that people may have. And if you do have any questions that pop up into your head after this, please visit the website or get in touch at wellintegrity@sentinel-subsea.com if there's any potential use cases you have in mind. And we're more than happy to discuss with anyone if that's the case. Thank you very much.
Thank you, Jim. That was excellent, and we had lots of engagement already for questions. So I'll start reading some of those out. Yeah. Steve gets the prize for first question. So well done, Steve. Thank you for that. Steve wants to know whether this is a subsea application. Do you have any system designed for onshore?
Interesting, yeah. So this technology as it's designed right now has been used primarily for the subsea environment. Now, we do have some thoughts around how we can apply this to the onshore environment, and that is something we would absolutely be keen to look into if that's a thought that's in somebody's mind, but we'd have to understand the scenario a bit better, and we can go into more detail, but we do have some thoughts around how it can be applied onshore, definitely. So I would encourage anyone who has that need to get in touch with Sentinel. As you've seen, the core of the technology is around the triggers, and how we use that really is based on what the industry needs are.
Great. Thanks, Jim. Another question is, does the system work on wells once they're fully P&A'd, so not suspended, but the well's still live, as the subsea wellhead is removed as part of the complete well P&A?
Absolutely, yeah. The system will work. We have systems across the full well life cycle, and I think I mentioned in the presentation there, we're looking at fully P&A'd wells as part of a CCUS project, where the system will actually sit. Maybe I can actually share my screen again just to answer that question. Yes, is the answer to that. This here is a system for a CCUS project that we have, where what we call the Well Sentinel limpet will actually sit over the fully abandoned well, and will then secure it in place on the mud line. And we can do different methods of anchoring it down, but essentially what that is it's an umbrella on the seabed that sits over where the well was. And then the monitoring module is the same as it was for the suspended wells or for the producing wells or for the development wells. It's all the same monitoring module. It's just the gathering structure that will change. And we can design that to fit any well scenario that you may have in place. So absolutely, yes, we can put that in place for any sort of well scenario that you have.
Great. What is the lifespan of the system? What is the main requirement frequency to retain its integrity and use as a safety system?
So there's 2 points here. The structural design, so the gathering structure and all the pieces are designed for 25 years subsea deployment. So we've got multiple different ways that we do that. We have a anti-foul coating in place. I didn't mention. And that's the kind of red part that's at the top of the canopy there. We have that. So the structure is designed for standard 25 years deployment. The monitoring module that's in place, we have two different types. Firstly, we have a 10-year system that can be installed for 10 years of continuous monitoring. Now, that can change based on water temperature. We've seen that in Australia when we deployed, but it wasn't a big change. So 10 years is the standard. And for the CCUS projects, we can go up to 20 years continuous deployment, maintaining integrity of that as well. So 10 years is the standard system, continuous deployment in place, and there's no intervention requirements as part of that as well.
Okay, that seems relatively... assume this has been approved for use by the safety regulator in the UK. Have NOPSEMA been engaged?
Yes, absolutely. In the UK, we've worked with numerous regulators globally already. We have been deployed in, as I mentioned, Gulf of Mexico, Brazil, the UK, Caspian, and Australia. We have spoken to NOPSEMA already, and they are aware of the technology, and we've used it in Australia for two different projects, one around the monitoring of an active suspended well, and the second one was in the use of that FPSO floataway that I mentioned, where the wells were suspended. Excuse me. The wells were suspended, so we are working. We have spoken to NOPSEMA, and they're aware of the technology. Yes.
Yeah, great. I was wondering, what's the CO2 minimum concentration threshold to detect gas leakage in a CCS well?
So we can set the sensitivity of the system. I will have to get back to the person on that question. I know it's 60 mils of fluid for the gas and the hydrocarbon, but I'll need to get back to that person on that question.
Sure, no worries. So Jim, can the system be reused or redeployed on other wells, or are they designed for single-use applications?
No, absolutely not. They are reusable. We have designed the system, especially so we have designed the coral, which is the wellhead system, so that it actually has an inner shoe on the inside, so that we can fit different wellhead profile types with the same system. So if you had a 5-year monitoring program, or 3-year monitoring program, or 2-year program, you could then recover the entire structure. We'd refurb that in locally, wherever that deployment is, and then we can then reinstall that absolutely onto a different wellhead. We would just change the shoes on the inside of the wellhead cap. And we had a project recently where we recovered one of our tree systems from a subsea tree that had been monitoring for 2 years in place, and then we redeployed that onto a different subsea tree. Again, took it back, reinstated parts of it, and then reinstalled that onto another tree. We just need to know, the only thing we would need to change is which triggers were installed. So if it was going from a well, like an oil well, to a gas well, we would then reinstall a different trigger. That would be the only material difference that we would need to do in terms of that. So understanding what the operator was looking to monitor for, then we could redeploy those systems easily.
Great. Just a reminder, if you have any questions, to put them there in the chat. I have another question, Jim. Are all the components manufactured and shipped from the UK, or do you have anything here already?
Absolutely, yeah. Our goal is to manufacture locally. Obviously, we don't want to be shipping these things from the UK or other areas. We want to minimize emissions, and we want to work with local companies as well. So, the gathering structures that we build, those have been built by local companies, and we worked with a great company in Australia when we were there, called Scope Engineering, who built our gathering structures and did a really brilliant job with that as well. So we work locally, and the only part that we would ship would be the monitoring module. That's the element that would need to be manufactured and built here in the UK, but they're not big. They're the size of a pedal bin, really, and we can ship that over quite easily, and then we would fit it in Australia, say, and then deploy it offshore, match it with the gathering structure, and then you're good to go. So we work locally, absolutely.
Yeah, good. Jim, can you tell me what the typical cost savings and emission reduction gains operators can expect when using your technology?
Absolutely. So I guess firstly, the emissions reduction. We did a third-party verification report here in the UK for a number of systems that showed the emissions reduction capability reduced because you weren't going out to inspect with diesel vessels, and the savings that was. I was meant to have the report in front of me, but I have forgotten to get it up. So, but there is a massive greenhouse gas emission saving as part of that. And then there's obviously the monitoring savings that can be made. An example of that would be where we had a operator who had a monitoring program because of the risk profile of that subsea well, had a monitoring program in place that required enhanced vessels deployed to the area to inspect. We managed, because of the reduced risk with this system installed, we got them from going out, I think it was monthly, to instead going out 4 times a year. So a huge amount of savings involved in that by reducing that risk profile. And also the ability, and I think this is important to mention as well, the ability to, because of the risk assessment reduction, the risk reduced on those wells, that gives operators the ability to do a lot of risk-based decision making around those wells. So there's a huge cost saving in that as well. Yeah.
Yeah, good. Jim, I saw a few people writing a minute ago, so I'll just give them a little bit of time if they wanted to finish their questions. Did you have any last closing remarks?
No. I hope we're really excited about the technology and bringing it to global markets like Australia. We think it can add a lot of value in terms of managing subsea assets and removing the complexity for managing those subsea assets. And I'd like to thank CODA and everyone here as well for setting this session up, and hopefully speak to some of you in the near future.
Absolutely. Jim, we have one more question. Could you please elaborate on the signal detection transfer between the field side and the operator's office desk? Like, how does that occur?
So there's different means of doing that. We are, with clients that we've worked so far, there's kind of two. We can feed the API into your own well integrity management system. So when that happens, the beacon would launch. It would then send a signal via the Iridium satellite network. Then that would then feed into whatever operating system the operator is using for their WIMS, and they would get that directly to their onshore base. We also have a portal here with Sentinel, where we would then, the system would then send an email, and we would also get that as well, and we would then call the operator to ensure that had been received. So there's different means of setting up that signal interface, and we would work with the operator. However you wanted to set that up, we can work. So there's different means of doing that.
Great. I think that is all the questions we have. So just wanted to thank everyone. Wait, hold on. There's a last minute question has just come through. Good timing. Jim, a great system and good to see now actively deployed. Can see the advantages of this over the conventional approach. Suggest opportunity for application to onshore, as there's a real need in Australia. So it's a conversation to continue. I know there was definite interest for onshore also with the regulator. So might be a continuing conversation for you.
Excellent. Yeah.
All right. Well, thank you everyone for coming. I hope.
Thank you.
Go ahead, Jim.
So I was just saying, if anyone does have any questions around the onshore, please reach out to that to Sentinel as well, because we do have some thoughts around how we can do that.
Absolutely. Thank you everyone for joining us today's webinar. Please join us again for the next one, and thank you again. Good afternoon.